I'm going to wander around a little bit down here. Before I get started, if I can get an idea of what the audience we have here, what is the industries that you're involved in? Oil and gas, who's oil and gas? Oil and gas, a couple. Anything energy, electric? Aerospace. Any sensors, analytics? And who did I miss? What is it? Smart cities, outstanding. I'm on my way to NASA next week to talk about urban air mobility. Yes, local government for here in Florida, Miami-Dade. Okay, thank you very much. My name is Lux. I'm the executive director of Assure. I'm going to talk about a little bit. There's a lot of ways I could have went today, and I just what I wanted to do is just give you a quick, broad brush of some of the research that we have done. One dive into, everybody's heard that there's well, not everybody, the FAA has just put out a notice of proposed rulemaking for operations over people. We work for the FAA. It is not what we have developed and figured out for the FAA. There's another group inside the FAA, independent, has done something. We'll talk about some of that today too. But during the panel session, I'm open to a wide range of everything from analytics to the challenges of urban air mobility, and you name it. We have a lot of different expertise in Assure, as you're going to see. You know, I don't have to preach to the choir here. UAVs, I come out of a military background, so I saw the explosion and was part of that explosion of capabilities and the amazing things they need to do. And really any mission that's dull, dangerous, or dirty, we've heard that before, is probably great for some kind of robotic system, drones being one of those. But as we move forward in that, there are many, many challenges. And that's where we work. And it's my kind of my second half of my lifetime, work lifetime, is focused on getting the regulatory risk away from everybody so they can be creative and start figuring out how to, turn it over to the smart people on, we can use a drone for this, robotics for that, AI for this and that. So that's where we move. And we've got very congested airspace. Great discussion today about urban mobility and that really cool machine. But how does it operate in a city environment when there's other cool machines moving around? Who's been in a city? We've got Miami-Dade. What do you see when you look out at the skyline? You see all these cranes. Every single day, a new crane goes up. All of these things are not currently accounted for in our air traffic control system, and we need to, kind of figure out how to overcome those challenges. So what I do want to do is, for anybody that's in the room, is kind of give you the FAA perspective of how they're moving. If you haven't heard that before, this is useful. You need to know how they are moving. I was on unfortunately, I didn't get to participate a whole lot yesterday. I was on an all-day phone call with the FAA since they came back to work, and they got about another week of work. They're doing their big dump on us on the research they need to do if they have to go away again for a little while. So I have a lot out of that phone call today to add. But you have to understand the way the FAA is thinking. But what we do as Assure and our universities and our industry partners is we can also influence regulation push research to get regulation in place to enable things that you need done. We just need to know about it. We have to have the concept of operations and what you're looking for, and with enough horsepower, we can kind of drive. So if you're off the beaten path, we need to know about it. I will take one deep dive into operations over people on one of the studies that we have done on what happens when people are hitting the ground. We've looked at cars, buildings, rooftops, but part of that study, the most interesting part, is what we've done with what happens when a UAV hits a human being. So for those who don't know Assure, we are a center of excellence. We're not a business entity. We have established a separate 501c3 so that we can be available to industry to work with their problems, and we are doing that. Other government agencies outside the FAA so that we can provide support and work for them. we provide that expertise that is not necessarily resident in the FAA, or there's not enough of that. We work, the way we're funded as a SURE, not a SURE Research and Development Corporation, that's our 501c3, is through grants and IDIQ contracts. The grants are definitely one-to-one cost share, so the universities have to have some interest in that area of what the FAA wants to do. They've given us their wish list of where they want research to do. We have plenty of capacity to cover that. So we've really been focused and driven by the FAA on the research versus the way some of the other centers of excellence work is a university-driven system. We also can do contracts with them for very specific deliverables and timelines, and the cost share is negotiable. You can see what our funding has been, and we're holding right now about $14 million on direct kind of the grant side of the house, of which you double that money because everything is 50-50 cost share. So industry support and then the universities themselves. Just a quick look at, just the universities that we have involved in Assure. What's not showing is our industry partners. They're key to all of this because those tend to be partners that have a high interest in something we're doing. For example, I'll talk about later, we are looking at engine ingest. What happens when a UAV goes down an engine? What kind of design features can we do to make sure that's not a catastrophic event? And of course, if you're GE engines, Pratt Whitney, Honeywell, Rolls-Royce, you probably have a little bit of an interest in this. So they have all come on board with Assure. They're actually designing an engine for us that is representative of all, but not any one of their engines, because it's just not going to look good when a UAV goes running down a Pratt Whitney or a GE or a Honeywell engine. And we're developing models and everything associated around the engine experts to get good modeling in place. That would be an example. Our core schools are the ones that can receive direct funding, and then we have a series of affiliates that now is spreading internationally. The FAA has asked me to lead a charge internationally on research and coordinating research worldwide. We're actually spending money or using other governments' money overseas to drive some of our research that we need here in the US. Okay, the strategic plan. Altitude, rural versus urban, as you move on this axis, and time is routine kind of over time. We've already know that we're working the rural airspaces with, right now it's line of sight type of operations. We're moving into beyond visual line of sight. So think of those precision ag that we've talked about that are away from most people, other type of traffic. That's where the FAA is starting. The FAA is also moving up here in the Class A airspace and treating it like any other aircraft for the most part. Right? The aircraft is to be certified to operate in that airspace. It has to have all the equipment, power to run it. Air traffic controllers are controlling that aircraft, and it's much, much more normal. There's still issues. We got data links that have never had to be looked at before that control. How do we make sure they're safe for cyber and all that? That's research that we're involved in. And as we move in over time, we start moving into that urban airspace. So great ideas and beautiful looking machine. I've been pushed out to NASA next week to try to start picking up in this area, but there are some significant challenges that we're going to work in there. So if you are a person that's thinking air mobility, package delivery, hospital response, there's a lot of things going on here that has to be very carefully coordinated and pushed up on your priority list. And I would say it's not necessarily scalable at this point. We can work small projects in that area.
What's the timeline on that? 10 years?
Great, that's a great question. We asked the FAA that, so their official answer on that is, because they're scared to death of Congress, is that's a notional timeline. When I've talked internally with them, they're looking, their rulemaking, everything's about 2 years, so they're out about 5 to 10 years when you look at this chart. So anything that we start today that we research, we usually take about a year, and then there's a rulemaking process. If they haven't started writing the rules while we're doing our research through our early findings. It's about a 2-year process before the rule actually becomes official. Now, you can start making adjustments to rules and waivers and things like that prior to that. This chart's very important in the FAA. And why it's important to them is this is the the step approach that they see moving forward. So depending on what you want to do, if you can relate it to operations over people, expanded operations meaning beyond visual line of sight, small package delivery, segregated operations with other aircraft, manned aircraft, generalized, not like routine scheduled cargo operations where we go to. I would think we'll probably look at, and we've already had discussions with like FedEx and UPS overseas working the transatlantic, trans-Pacific type operations. And then eventually, back in the day, we used to have elevator operators. Before, I'm not that old, but I've seen the old movies, right, where there's a guy in the elevator. We also have had to have train operators. But if you go to some of the airports these days, a lot of those trains that are moving around the airport have no operator. So as crazy as it seems, I'm a pilot. I don't know if I want to get on an airplane without another human being that has skin in the game. We're looking at commercial applications in the future. So the research. I just put up that here's all our kind of completed projects. It was about $18 million worth of work. We've looked at certification cases. I'll talk more about this beyond visual line of sight work. Here's our collision studies. We started with looking at what happens when it hits an airliner or a business jet or an engine. That led into, you're going to see in the next thing, of course, a lot of concern by Congress and the public when we announced all that, so we got more research to do in that area. A whole section on maintenance. Obviously, you have a DJI Phantom 3. You don't need to keep all kinds of logbooks on maintenance and repair and replacement of parts. You chuck it and put a new one in, or you send it back to DJI and they send you a new bird. But if you have a Global Hawk or some other system that's up and is large, you're going to have to follow normal practices. We've offered how to do that to the FAA and how they could potentially regulate that. Sense and avoid is detect and avoid. There's a whole human factors section because we have controllers, right, that are flying operators that fly those aircraft. You'll hear from one right after I'm done here. So there's a whole bunch of human factors issues that need to be regulated, defined. What does a ground station need to look like? What is the environment? What works outside? Glare. All those kind of issues. We talked real briefly, I mentioned secure, command and control, interference, cyber attack. Anytime when there's an aperture, there's a chance for somebody to get in your system. How are we going to work that problem? We've done some initial work there for the FAA. We've done also down here UAS, think counter UAS, but the FAA has no authority to shoot down its own aircraft. So it was the detection side all the way up to any kind of activities to bring the aircraft down. Current federal regulations prevent that. You cannot shoot down an aircraft. You cannot jam it. There's all kinds of special rules unless you are DHS, Secret Service, and portions of the FBI. They've been given some authorities. Obviously not in the United States. So there are no military applications. So that's external to the United States. That's where the technologies reside. We did a bunch of testing on those technologies, and what we basically reported, it's very sensitive, but overall what we presented to the FAA is it's not ready for prime time. So it's not necessarily worth equipping all your airfields to go out and do this because what we found is it's just not mature enough right now. So where we are today, I'll brief the ground collision study work that has gone in the past, where we are, and that's operations over people. We are heavily involved in science, technology, and engineering and math development for everywhere from about senior elementary school through high school and even now into college. So the FAA gives us some money, and our schools are all involved in providing programs, summer programs, camps, and stuff to get kids excited. Here's our airborne collision study that came out of the commercial test. There was concern about general aviation aircraft and rotorcraft. So we're going to be doing a lot of work there. And then this will be our first look at everything is pure center of gravity on center of gravity hits. We haven't looked at probabilities yet. Well, this study will also look at, for the first time, the boundary layer at, let's say, a wing. As it comes in, the UAV with the boundary layer will start deflecting. What is the likelihood of a center of gravity on center of gravity hit? And when it offsets, we've already done some of that research. We know how it significantly decreases physical damage as it deflects. So it's very important. For the first time, we had a little money left over to look at that. The engine work, I mentioned that earlier. That involves all the commercial aircraft engine manufacturers of about a 737 Airbus 320 type aircraft. Detect and avoid this summer. They're doing all around the United States. We're bringing in different folks that have concepts of operation where they need beyond visual line of sight. So if you're a power company that has transmission lines, you want beyond visual line of sight. Oil line inspections, all that kind of stuff. Ag for farmers. We'll be looking at all their concepts of operation and detect and avoid systems, and we will establish with the FAA the minimum standards required, performance standard required, and methodologies to get certified for beyond visual line of sight operations. These two down here are very interesting. There's a lot of data that's out there now. The FAA doesn't get it in a form or format that's useful to them. So we are in the process, one of the calls yesterday was defining what the data is, how we're going to receive it, and then how we can quickly turn that into, let's say you have a waiver you want to go fly at night beyond visual line of sight. Okay, we're going to provide you a framework, or the FAA will provide you a framework with maybe has already, like we know a certain UAV already has navigation lights for nighttime operations. You don't have to describe it. You don't have to do anything. It's boom, it pops up as a check. That whole line doesn't even have to be worked on anymore. And now you move on to your beyond visual line of sight, where you're operating, what are the risks, what are the mitigations, and things like that. So that should be coming into effect over the next couple of years. We're just starting that project. It's a one-year project. And then following that, it'll be much more the implementation systems, although the FAA is already moving into, they like it, they're moving into basically managing this by Excel spreadsheet. Not great, but at least we don't have as much repetitive things going on. For example, if it's easy, we don't want to waste FAA time as well as your money and commercial time trying to figure it out. It's bogging down the FAA, so once something's approved, they want to know, okay, it was approved in this situation. Here's the standards that's now good. You don't need to worry about it, so to cut down on applications. And the same thing with the study right below that. It'll be, okay, when you report, what is the data we care about? If it's all normal, we don't need to collect that. All we need to collect is maybe how many hours of normal activity, but then when did that exceedance occur? When did the problem occur? How many per flight hour and things like that. And then down here on the bottom, 2 contracts that the FAA is looking to lay with us, and there's actually a third now, is e-commerce. We're going to go out and, of course, Google, Walmart, everybody's very protective of that, but we are working, what will the national airspace look at like in another 10 years, given that they're allowed to do package delivery? What are the effects on the national airspace system? What adjustments does the FAA need to make or rules put in place to help manage this new airspace? Soup to nuts on a safety case. You have a problem, how to potentially solve that problem and get it approved through the FAA. And then the final one that has just been thrown at us, initial efforts about $2 million, for the FAA, for us to go research with other federal agencies, think FEMA, think local, state and local authorities, disaster preparedness and disaster relief. How do we get this stuff going? We'll probably pick a state or a series of states. We'll use different disasters to build the templates so that the FAA is much quicker in response when something happens, the states, just like FEMA, has learned how to kind of control or coordinate is a better term. We got to get the FAA in that mix, and that's the goal there. Okay, so ops over people. So the FAA, in what you're going to see in the restrictions are basically thinking in terms of what we have always regulated on our national ranges, which are missile systems and bombs being dropped and things like that, hard metal type situations. And you'll see that represented over here by a wood block, and I'll talk more about that. Notice when that wood block hits the crash test dummy, it stays on the head. There's a retention line that eventually pulls it away so it doesn't damage equipment below. But over here, watch what happens with the DJI Phantom when it hits. You'll see it flex and bow and roll and twist and bounce off the head like a spring. When that block lays on the head, that's energy transferred directly to the noggin. When this thing flexes and bounces off the head, that's energy maintained in the UAV as it flips around, and the materials probably compress a little bit, but that's energy not transferred to the individual. And that'll become more important on the next slide. So here we go, I think. So you can see all that flex and turn, the block's now being pulled off. Okay, that becomes pretty interesting. So when we did our initial look at what happens to people on the ground, we were telling the FAA that the probability of this contact, of which they believed was 100% fatal, nearly 98 to 99% fatal, only had a 0.01 to 0.03%. You guys are screwed up. Your test dummy is not reading it. You're wrong. This is not right, going on. So what we then did is, with our methodology, we took a wood block, which is part wood, steel, and we did steel block too. I just highlight this here. And where the Range Commander Council's materials and everything else, we used our system and we basically got the same numbers as them. So there's something different, obviously, between a steel block, piece of hardwood, and an elastic UAV. So the FAA sent us back and said, okay, here's some more money. We don't believe you, but we kind of believe you, and let's move forward. So we did a bunch of failure modes with a variety of UASs. And what those flight tests were meant to do is we failed single motors, multi-motors. If it was fixed wing, deflections of ailerons and all that kind of stuff to identify the worst, the most probable worst case scenario of if it hit in your noggin or your side of your head or whatever. We took that and we ran it out at NIAR at Wichita State, the full ATT crash test dummy. So think about a UAV hitting a crash test dummy. The FAA has asked us to develop a more simplified, because this is expensive. Can we do a more simplified dummy of which we just lopped off the head of the poor ATD and built it into another system to make it a little easier? So we use that, and we're developing models so that in the future, once we get these parameters, we can eventually throw it into different human body modeling and head modeling, so any new system comes along, it's quicker, it's faster, and cheaper to do the testing. Finally, all validated by, we had donated to us 5 cadavers, of which we did a lot of testing on to validate our work. So what you're going to see here is just some examples. So the EB, who knows, everybody should know about this foam aircraft. It's fantastic for operations over people, and basically that's what we've said. But you'll see how close the actual versus our modeling even looks as they crash. All that flexing and crunching is good. All that energy is going into the deformation of the foam. But what we also found in these studies is there's different injury mechanisms. You get hit really hard and quick, that initial shock can fracture skull. But you can also have, in this case, even though it is safe, we've looked at what we think are, and what medical people think are the actual worst case scenarios. But notice how long this stays on the head. So that's energy that maintains on the head and it increases compression in the neck. Now, fortunately, enough deformation and everything takes place in the vehicle itself for all its different failure modes that that's not a factor. But with other aircraft, just simply using foam does not necessarily solve your problem. And here's the simplified test, same thing. I'm reading the reports right now as we're getting ready to go to peer review and submit them to the FAA for peer review. You'll notice here, this one, the head is a little stiffer than a full ATD, and we're getting a slightly different results with things fracturing that don't quite do that. So we're having to figure out what we want to do, and the recommendation is probably for fixed wing foam type crashes, we probably will not use that. We're going to have to develop something else. But for all our quadcopters that we tested, it worked fantastic. It matched these, and then it matched our post-mortem human study test. And just to show you a Phantom 3, comparatively, what happened on the crash test dummy and how good the modeling is. It takes a lot of time. We've been able to do enough Phantom 3 because they're everywhere and have them, and we've been testing them for so long that it's now statistically significant. And you can even see like cameras flying off almost in the same direction, and it's really getting reliable type testing. The only problem is about the time we get that reliable, they make a change, right? And we have to do another. And then finally, we're looking at internal models of what happens to the brain in the upper spinal cord. I got to participate in one of the autopsies, and that was the one where we had a fracture and a blown out a neck. That was interesting, but it was what we call an AAS-2 level injury, not fatal, or not even likely to be fatal. But that individual's going to have a few fused vertebrae. Not good. But we're supposed to only be. The FAA has told us to go for AAS-3, which are moderate to severe injuries, 30% chance of those, and this is below that. What we found on concussion is very highly likely, but simple concussion is an AIS-1. To get to AIS-3 is getting to be pretty severe in our parlance with sports injury. But concussion, we're having a tough time with the medical industry, and they're having a tough time with themselves figuring out what is the mechanism that best determines concussion and level of concussion. So with that, I will stop. I just wanted to give you one example of the study. So we are working with the FAA itself to overcome the current notice, the proposed rulemaking that is limiting the weights that you saw in that point. Why that is important? Layman. When I look at the weights and I look at all the charts, what would be about a limit of 2.5 pounds for a drone of certain flexibility, you can almost go order of magnitude more to like a 25-pound drone. Now, that doesn't necessarily apply directly. My point being, it's made out of the same material, same flex, same response. It's significantly more weight than the FAA is currently looking to regulate. So we are working with the FAA itself on the best, how do we respond to this notice and try to either slow it down and wait to these results, because we have not presented these officially to the FAA yet. The sponsors, everybody has seen it, the cert folks have seen it, the regulators, the people that write the rules have not. So with that, I'll hold questions until after Jake talks. Thank you.